So we have a data model. We have a course class, and certainly we want to be able to bind that somehow and say, well, whatever happens to this record, whatever happens to this object instance in memory, we want that to happen in the database, right? We want it to insert, update, delete, and whatnot. If I create a new instance object, somehow I want that to be inserted into the database. If I have a whole bunch of records in the database, I want to be able to retrieve them as a list of course instances. Yeah, so how do we do that? Same thing with courses, right? I like to bind that with XML, right? And say that, hey, this class maps to that XML document, and that these fields map to these attributes or map to these elements in the XML document. So let's first tackle binding to the XML document. Basically, we're going to need a table that is called courses, right? That has two fields, the ID and the title, and the primary key is ID. So we can already picture in our mind that the fields ID and title are identical, spelled out, and also in case sensitive. They're the same name of our fields in our class, right? So we could already imagine that probably is easy to map. The only difference here is that notice that our table is called courses, plural, but our class is called course. Yes, that's also a naming convention in Java. Typically, when you instantiate when you create a class, typically you use singular. Yes, the classes are singular. Whereas when you implement a table in SQL, typically the naming convention is that you use plurals. All right. So somehow we're going to have to finagle our way through that, right, and map these two worlds. Also here I've inserted two records, CS5610 and 3500, into the courses table. So let's map this. So the way we're going to map this is that we're going to decorate. We're going to use the decorator pattern. We're going to decorate our class, right, with a couple of decorators: the entity decorator and the table decorator. Right. The entity decorator is going to say, hey, this class somehow is going to be mapped to some table, right, in the database. Right. By default, if you just leave it entity, it will map it to a table that has the same name as the class. Since the class name is course, it will try and map it to a table also called course, right, singular. Yes? But instead, we want to actually map it to a different table that has slightly different name, right, which is plural instead. Right? For that, we're going to use an additional decorator, the table decorator, where we can override the default name of the table, and we'll say actually the name of the table that I want to map it to is courses, not course. Make sense? That's easy. A couple other decorators. We're going to decorate the automatically the ID field. The ID property here and the title property here in the class will automatically map to the table ID field and the title field without me doing anything. Right? I could also override the name of the fields that I want to map to, but I'm going to leave that because ID and title are perfect. You know, they're lowercase, they're singular, and they map perfectly to the tables. I am going to decorate it as letting the JPA, the Java Persistence API, know that actually this field ID, that's actually a primary key. All right? That's going to map to primary key on the database. Also, we need to guarantee that this field will always be unique. Right? Not because Java cares, because Java instances are already unique. Yes, and without doing anything. But the table cares, the database cares, right? That all these values are unique, and so we need to define how is it that we're going to guarantee that it is unique. So for that, we're going to use a strategy pattern, a mixture of the decorator pattern with a strategy pattern, and we're going to say, well, how is it that you're going to guarantee that this is unique? Well, one strategy is that I'll handle it. I'll make sure that every time I create this ID, maybe I use a GUID or some random generator or whatever, right? And I'm responsible for this, to do this. But every time I instantiate an instance, that's very painful. We're not going to do that. Or we can delegate it to a database and say, hey, database, you handle it, right? You make sure that these fields are unique. And for that, there's different strategies, right? Different vendors use different strategies. Oracle uses a strategy of creating a very long sequence of unique values from where you can then choose, right? And just say, well, give me the next unique value, right? So it creates a really long list, right? 1, 2, 3, 4 until very, really, really big, and then just grab one number from there. That's a very crappy strategy. The other strategy is the way MySQL does it is that it just uses a command on the ID field called auto increment, meaning just look at the last one, right, the last value, and just increment it by 1, and it gives you the next unique identifier. Make sense? All right. So different vendors use different strategies. So here you can turn on the strategy that you want. Where you can say, this is a generated value, and the strategy I'm going to use is the identity strategy, meaning different vendors implement it differently. That's the adapter pattern. MySQL implements it with a tag calling auto increment, whereas SQL Server implements it with the keyword identity. Right. So again, different dialects, right, of different vendors. But here we have an enumerated data type that allows you to say, well, which strategy you want. Right. I'm going to delegate it to the database to do that for us. Okay, let's do that. Let's go in here. Let's go back to our course and let's start decorating it. So we'll use the entity here, right? And I'm also going to decorate it as a table. And the name is going to be course says. Okay. And we're also going to decorate the this ID as a primary key. And I'm also going to say I don't want to handle the generation of this value. Instead, I am going to delegate it to a database. And I want the database to use the following strategy. Generated and identity. There we go. All right, that's it. That's this class is now bound to the database. Whatever I do to object instances of this class will affect records in the database. All right, and we'll see how to do that in a minute. All right, excellent. So we tied it. We tied it. If we compile this, see if this is going to install. Let's see if this blows up. This is going to blow up. What? Let's see. Where am I? Oh, I'm not in the wrong. I'm in the wrong place. I'm going to db. There we go. And now I'm in the project. I'm looking for the POM file here. Now we can do maven clean install. That's going to compile, link, and package the project into a jar file, an executable jar file under the target. So it looks like we're OK. Nothing blew up. OK, build was successful. Let's keep going. All right, so we bound that. All right, so to talk to the database, to actually talk to the database, right, we want to minimize our dependencies of actually talking to the database as much as possible. And that's what JPA tries to do. It tries to insulate us as much as it can to actually interacting with the database. Since there are different vendors, if each vendor has its own unique idiosyncrasies. So the way it insulates it from the database is that you can create a class or interface called a repository class that is going to handle most of the communication with the database, grabbing a hold of a connection to the database, sending the actual command. Right? You just need to tell it what are the things that you want to do with the database, right? And tell it what are the commands that you want to use. So for instance, one of the things I like to be able to do is retrieve all the courses, right? So I can implement my find all courses. And the other ones I want to be able to retrieve an individual course. And I need to convert that into some SQL command, right? Now remember that I told you that SQL has different versions, different vendors have their own idiosyncrasies, have their own dialect. So what JPA allows us to do is use a canonical version of SQL, right? That is not tied to any particular vendor, is not tied to any particular version, right? It actually looks very, very object-oriented. Right? Select course, right, from course, right? Where course ID equal course ID. It looks almost like SQL, but not quite. I don't know, anybody has taken 3200 or any database course? Right, yeah. So it looks almost like SQL, right? But not quite, right? So here, course is actually the class course, right? And course is actually an instance course of the course class. And this is actually a field, inside of the course instance. And I'm matching it against, a parameter that I'm passing in here. So these two functions are going to allow us to call this function, pass parameters, and then these will be converted into SQL that will go out to a database, and the database will respond. Make sense? All right? And it's through an interface. So let's do that. Let's do that, and we'll do that in a different package. We'll create here a package. I'll call it repositories. These are the repositories, and we'll implement. These are actually interfaces, and this will be the course repository. Okay. We're not actually going to implement it. Instead, we're going to extend somebody who already implements a lot of this behavior. We're going to extend a CRUD repository. A CRUD repository, as the name suggests, you might guess it, right? It allows you to create, read, update, delete to a database. We need to configure it, saying what is it that you're writing to the database? What are you reading from a database? We are writing courses, the course class. It also needs to know what the type of the primary key is. Are you using a long, an integer, a varchar? What are you using? I'm using just integers. Our primary key is an integer. And in here, we want to create a couple of queries. We're going to say, I want to be able to execute the following queries. The query is that I want to be able to select all the courses from courses with no filter, meaning I want all of them. Give me all the courses. And the other query that I want is I want to be able to execute, I want to retrieve only those courses, or that one particular course, where the course.id matches some parameter that I'm going to pass in, CID, some course ID. Okay? And I want to be able to invoke these from Java using the following functions. Right? The public. This will return, presumably, if it's a whole bunch of courses. Ideally, it will come back as a list of courses. Find all courses. Right? And this one I want to trigger using the function. I want to retrieve one function, one course. Find course by ID. For course by ID, and I'll pass you the ID, as an integer course ID, and I need to map this course ID parameter that I'm passing the function. I need to map it to this placeholder in SQL, right? I need to map that somehow, this incoming parameter to this placeholder right here. Placeholder. Notice that it's a colon here, meaning this is a placeholder. Right, that is dynamically injected in there. And the way we do that is that, hey, map this parameter, the following parameter, the CID parameter that is in this placeholder here, grab it from this incoming course ID that is coming passed into the function. Everybody okay? Yes? So the DAO is going to, so this is very low level, well, very low level. It's already lots and lots of abstractions. The DAO is going to be written in terms of this. Right, so the DAO is going to hide the fact that internally we are using this database specific communication. And the DAO could be written in other ways, like JDBC, or it could be written in so many other different ways. In this particular case, we're using JPA. So DDAO is going to hide that from us. Okay? All right, so we have that. We have our axis. And let's implement now the DAO. Now we can implement the DAO, and we'll write it in terms of that repository we just wrote. You know, if you remember, this was the interface, you know, course DB DAO. Let's implement this, and we'll implement it in terms of the repository we just created. Right. So let's do that. Let's implement the interface, and I think we put it under DAOs. And we'll implement this interface right here with a class and say this will be course DB DAO. And it's going to implement our interface. So this implements the I course DB DAO. And I'll bring in all those methods. There they are. So I want to be. I'm going to write this, the implementation of this, in terms of this low-level data access repository that JPA gives me. It's very generic. So how do I get it here in here, right? Somehow I need an instance of the repository. Yes. Now here's a couple more design patterns. One design pattern is what we briefly talked about, the singleton design pattern, when we were doing. Actually, I think we were creating in the. We're using the adapters, right? And I think one of them used the singleton. We create a single instance of an object. Yes. So the singleton pattern says there are some objects, right, some classes that are not meant to have, you know, lots of these instances of these classes running around in your application, right? Usually, some of these classes are only meant to have a single instance, which is then shared amongst everybody. Okay, and perhaps it has a very common utility kind of access that should be accessible all throughout the applications, almost like a global, right? Usually I'm not even responsible for instantiating it, right? And somehow I just want to get the same instance everywhere in the application. So that's one of the design patterns we're going to use right now. The other design pattern, which I guess we briefly touched upon, like factory patterns, right? Where instantiating certain things, we want to delegate that somehow and says, well, I don't want to deal with having to instantiate these things, right? Instead, I'm going to delegate it to somebody who knows how to create these instances. And by the time I want it, I'm just going to ask for this instance, and I'll get this instance, right? It's not my responsibility to manage the life cycle of this object, right? I'll just ask for an instance, and I'll get it. Yes? Right. So we're going to use that pattern too. And finally, the third design pattern is inversion of control, where we're going to we're not going to be responsible for instantiating these things. Instead, we're going to ask the framework, hey, framework, I know you have these instances somehow being instantiated by your design by your factory patterns and whatnot. Hey, I want an instance of that, right? And I don't want to manage its life cycle. Inject it somehow, right, inside of my or pass it to me maybe in my constructor. Right, pass it to me, my constructor, and will automatically be passing to your constructor on demand. Right? So all those three design patterns, are encapsulated in a single decorator called autowired. Right, autowired. Whatever you ask for here, whatever class instance you ask for, it will try to instantiate it for you. Right? It'll keep a single instance of this for anyone who asks for it, and whoever asks for it by autowire, it'll be made available to you as an instance. Right? So you don't have to say new. Right? The infrastructure will create it for you, and by the time you get to it here, will be available to you. So what are we asking for? We're asking for that repository, right? We're asking for the course repository, right? Create an instance of that repository, keep it around, right? Because I'm going to need it in different places. right? It's just one instance of this, inject it, and now I have it available. Right? Lots and lots of magic happening. So to implement my find all courses, I'm just going to implement it right here. So this will be, so repository is basically just calling my find all courses in the repository, right? And same thing here. The find course by ID will be the same thing. It's a repository dot find course by ID, and I'm passing it the course ID. Okay. All right. So that implementation, it's using the autowire course repository, implementing both of these. Right. I forgot to put override. Right. So this autowire, the way this works is that you can really basically autowire anything, any class out there that you want to reuse, somewhere else, and you don't want to use new, right? And you want to use this factory pattern that instantiates these things and automatically get injected into your variables. You could do that yourself, like this class we just created, right? This brand new class. If I wanted to use it elsewhere, right, and inject it, I can do that too, right? By decorating it. I can decorate it that this is a service. It's a service, right? And so that now anyone who wants to ask for instances of this class, they can just autowire this into their own space. Okay, all right. So the course repository internally it has a service decorator in there, the implementation. The only other thing is that this implementation, we are going to, remember, we're trying to do the adapter pattern, right? And the adapter pattern is going to inherit from this, yes, but it's going to implement another interface. Remember that? Right? That's what the adapter pattern does, right? It inherits from a previous implementation, but it implements a different interface, yes? So that's going to screw us up a little bit. The autowire mechanism works when there's only one course DB DAO, right? It's unambiguous that this is the one you want to inject, yes? But if you inherit, then it's kind of like you have another course DB DAO, right? Because they both are inheriting from the same base class. So the autowire mechanism is going to be confused and say, well, which one do you mean? Do you mean this one, or do you mean the other one, which is inheriting from this one? Yes, all right. So to break that confusion, we can name them. We can give them separate names. We can qualify them. We can give them name. Usually, it only uses a class name. It uses the class name. So we're gonna say we're gonna qualifier. And value. There we go. Okay. All right. So we have our DAO. Presumably is accessing the database. So we're bound to the database. So now, ideally, we'd be able to actually use this, right, and connect to a database. I'm going to skip XML binding for now. I'm going to jump to actually trying this out and testing it, see if this actually works. I'm going to skip that over for a second. And I'm going to skip over to HTTP binding, meaning I have this database. It's I want to actually use it to retrieve data from a database. How do I test it? I guess we could write a JUnit test to try it out. Bring this DAO and try it out and run it and see if we get some data. I thought it would be more interesting if we go a little further and look at HTTP binding.